Welcome to the NJIT website and math podcast. My name is Vanessa, and today I will be covering properties of absolute values. So before we dive into the properties, it's important to specifically get clear what an absolute value is. Because a lot of people just say, oh, it's whatever the number is, you make it positive, and you're done. Which is technically true, but once you get into more complicated expressions, I think it's important that you know exactly what defines an absolute value. An absolute value is simply the distance between the origin and any real value, which can be related to in real life by saying, I walk 10 feet. I can walk 10 feet forward, 10 feet backward, but you never say, I walked negative 10 feet. Because distance is always considered a positive number. Well, that's all really an absolute value is, except it's on a number line. Distance between 0 and any number, whether it's positive or negative, is considered a positive number. So let's just look at a number line so that we can get this clear. So say I had a number line here. Here's my 0. And say I wanted to go to 3. 1, 2, 3. 1, 2, 3. Okay, how many units does it take to travel from 0 to 3? Naturally, 1, 2, 3. So we take 3 units, which makes sense, no big deal. Let's say we wanted to go to negative 3. Negative 1, negative 2, negative 3. Alright, so same thing. How many units does it take to go from 0 to negative 3? 1, 2, 3. We also traveled 3 units, just in a different direction. So if we wanted to express that in notation form, the absolute value, which is the bar on each side of the number, so say if we had the absolute value of minus 3, it took us 3 units to travel from 0 to minus 3, which is why the absolute value of minus 3 is 3. And the same thing can be said for positive 3. It took us 3 units to go from 0 to positive 3, so our absolute value is 3. And that's all an absolute value really is. So now there are certain properties that when you begin to apply absolute value to expressions and you want to solve it, there are certain properties that might be useful to remember to make your solving a little bit easier. So let's just go with the most obvious property, which is that any number that's in an absolute value, when you solve it, the answer is always going to be greater than or equal to 0. Again, because distance is a positive number. So if we say had the absolute value of minus 5, it takes us 5 units to go from 0 to negative 5, so that's why our absolute value is 5, which is obviously greater than 0. So the next property is that any positive number, its absolute value and the absolute value of its negative version are always going to have the same answer. Just like the example that we did on the number line, the absolute value of negative 3 is going to be equal to the absolute value of 3, which is 3, because it takes 3 units to go to negative 3 and 3 units to go to positive 3. They're mirror images of each other, so the distance is going to be the same. It's like saying, if you start at one point and you walk 10 feet to the left, your friend walks 10 feet to the right, you walked in different directions, but you traveled the same exact distance. Same concept. So now what happens when you introduce absolute value into an order of operations? First, let's look at multiplication. Say we had the example positive 3 times negative 5 in absolute value. So the same thing is that because absolute value usually pertains to the distance from a value from the origin, you can split the absolute value to the specific values, to each specific value except aside from the overall expression. So this can be regarded as splitting it up is going to be the absolute value of 3 times the absolute value of negative 5, which is same thing as 3 times positive 5, since the absolute value of negative 5 is 5. And the same concept can be done for division. So if you had, say, absolute value of minus 7 over 3, you can split the absolute value to individual values. So this is the same thing as saying absolute value of minus 7 over absolute value of 3, which is just 7 over 3. Right? So that's multiplication and division. How about subtraction? Well, now you know in subtraction, when you do normal run-of-the-mill subtraction, you're taught that you cannot switch the values, otherwise you're going to get a different answer. So say if we did 2 minus 7, that gives us a minus 5. If we did 7 minus 2, that gives us positive 5. Naturally, two different answers, but look at the resemblance. It's the same number, just with a different sign. So, but when you throw the absolute value in, it eliminates that problem, and you can actually switch them. So you can say that the absolute value of 2 minus 7 is the same thing as the absolute value of 7 minus 2. Because if we work them out individually, look what happens. You get 2 minus 7, which is the absolute value of minus 5. Absolute value of minus 5 is 5, correct? What about the other side? 7 minus 2, you get the absolute value of 5. Absolute value of 5 is 5. Same exact answer. Because the answer, both answers are always going to come out positive, you're always going to get the same answer if you're doing subtraction. Now the final order of operation would be addition. Now it's not the same as subtraction where they actually come out equal. There's something that's called the triangle inequality property, which applies to absolute value when you have addition. So what the property states is that if you have two numbers, such as, let's say, minus 2 plus 5, this quantity is always going to be less than or equal to if you were to split them up. Minus 2 absolute value of 5. And that's always going to be the case when you have addition, is that the absolute value of the sum within the absolute value is always going to be less than or equal to the sum of the absolute values individually. So let's try it. So if you have negative 2 plus 5, here you get absolute value of negative 3. Absolute value of negative 3 is 3. And on the other side, we have absolute value of negative 2 is 2. Absolute value of 5 is 5. 2 plus 5 is 7. 3 is obviously smaller than 7. So that's what that property does. And it's known as the triangle inequality. So thank you for visiting the NJIT website. If you need any further assistance, please feel free to stop by the CAPE, or the Center for Academic and Professional Enrichment, located in Kupfrian Hall, room 200. Good luck in your studies.